simplify this, you're going to leave the -4 alone right now. You're just going to worry about the 75. So you're going to take the 75 and you are going to use your prime factorization there. So based on this, I can see that a 5 will come out and a 3 will stay in. I already have a -4 out here. I'm going to multiply by that 5 that I'm taking out. And then I am going to look at my variable, the m cubed. I'm going to take that exponent and divide by 2. 3 divided by 2 is 1 with the remainder of 1. This first tells you how many come out. The second one still tells you how many stay in. So I have 1 m that will come out and 1 m that will stay in with the 3. So on the outside, I have the -4, the 5 from my number, and 1 of the m's. -4, 5, and 1 m. On the inside, I have the 3 and 1 of the m's that stays in. And then to simplify this and get it finished, I have to multiply everything that's on the outside and multiply everything that's on the inside. -4 times 5 is -20 times m, and then square root of 3m. That would be my answer. All right, let's look at the next one. For this one, I have 12v squared and 6v squared on the inside, and they're multiplying, so I multiply them. Now, here's the deal. When you're doing this, you can go ahead and multiply 12 times 6. What is that? 72, but you actually don't even have to worry because you're about to factor it, okay? So you can just go ahead and factor the 12 and the 6, but just remember that everything from those factors can be grouped up. So I can say 2 times 6 here, 2 times 3. This is also 2 and 3, right? And so I can actually group up anything with those factors from 12 and 6. I can group up any of those factors. So I can say, well, these factor, so those can come out. These have paired up, so those can come out. And this 2 does not, so that will stay in. And then don't forget, when you are multiplying these, you add their exponents, so it ends up being 4. So you do that 4 divided by 2, that's 2 with the remainder of 0, which means 2 of your v's are going to come out. None of them are going to stay in. So to finish this, you just multiply this, 2, 3, and v squared is 6, v squared, and then you still have that 2 on the inside. If either of those had a root, I would go ahead and do that first. And then remember, if you have things on the outside, those can reduce, and things on the inside can reduce. So based on what's on the inside, can anything reduce here? Between the things on the inside, the square root of 3 and the square root of 6, they're both on the inside. Yeah, you can reduce by 3. So if they're both on the inside, you can reduce them 1 and 2 there. All right, makes sense? So 5 times the square root of 1 over the square root of 2. Now, does anything have a perfect root? 1 has a perfect root. What is the root of 1? What times itself equals 1? 1. So on the top, this is just simplified to 5 times 1 over the square root of 2, which is 5 over the square root of 2. So before we do anything, we can simplify that, okay? Now, we don't want to leave a radical in the denominator, so I have to multiply the top and the bottom by that radical. All right, on the top, you simply have 5 times the square root of 2. On the bottom, when you multiply a radical by itself, or when you square it, what happens? It just becomes 2. The square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. So anytime you multiply a radical by itself, you get what is inside. Now here, the 5 is on the outside and the 2 is on the outside. I cannot reduce that. We have a square root of 2 on the inside in the numerator. I can't reduce with that with anything. So this is my final answer here. 5 square root of 2 over 2. Now, you could have, I'm going to show you another way here. You could have just started, okay, 3 doesn't have a root, 6 doesn't have a root, and you could have gone straight here. If you do it that way, you're going to end up reducing later because I can simplify the square root of 18, okay? I can simplify it using my factor tree, 2, 9, 3, and 3. So I end up with like 5 times 3 square root of 2 over 6. And then the 3 and the 6 can reduce there. And you end up with 5 squared of 2 over 2. Okay, so either way you do it, you're going to end up with the same answer. You either have to reduce it at the beginning or you have to reduce it at the end, one way or the other. Pay attention to your instructions as to whether it wants you to just leave it as a square root if it doesn't have a perfect root, or if it wants you to plug it in and actually give me a decimal. All right? So for this one, which side is my hypotenuse? For 19, which side is my hypotenuse? 4. So that is going to be my C. The A and B do not matter which way you put them or which order you put them in because they're adding, but the C matters. So I'm going to say A squared plus B squared equals C squared. All right? Now, square root of 14 squared. I am just multiplying the square root of 14 times the square root of 14. What is any radical if you multiply it by itself? It's what's on the inside. And so this one's just going to become 14. What is 4 squared? 16. How do I solve this? Subtract my 14 from both sides. So I get x squared equals 2. How do I solve this? Square root of both sides, right? Now, on our last chapter, you would tell me positive or negative root of 2. I am talking about the length of something. The length of something cannot be negative. It is always a positive number for the length. So the x is just going to equal the square root of 2. Can I simplify the square root of 2? It's a prime number, right? I can't do anything with it. It does not have a perfect root. It's already prime. That is my answer. X equals the square root of 2 is my answer. So for this one, which is my C?
Please evacuate the
Number 20, what is your hypotenuse here? 16, so that is your C.
gym cleared.
X squared plus 4 squared equals 16 squared. All right, what is 4 squared? 16 squared. Hopefully that you got. Subtract 16 from both sides. All right, x squared equals 240. Does 240 have a perfect root? No, it does not. Your instruction said leave in radical form. So how do you simplify this root then? Factor tree. And so you're going to do factor tree. It's going to be a big one, right? But it works out. All right. Factor tree looks like that. And then if it pairs up, it comes out. So I have 2 that comes out. I have another 2 that comes out. The 3 does not pair up and the 5 does not pair up. So inside I have a 3 and a 5. So you multiply the outside 4, you multiply the inside 15. So your side here is 4 square root of 15. Your distance formula is very similar to your Pythagorean theorem because it is based on that. You do need to know this formula. And then your midpoint formula is just adding them up and dividing by 2. So your distance is going to be one number. Your midpoint is going to be a point, meaning an x, y. All right, you have to know those formulas. It does not matter which way you subtract. Normally that would matter, but you subtract and square. And so if you subtract one way or subtract the other way, as long as you subtract your x's and square it, and subtract your y's and square it, you will do it correctly because you are squaring it, so the negatives really won't matter when you do the subtraction. All right, so if I plug this in, I'm going to get -3 minus 4 squared plus -1 minus 7 squared. All right, -3 minus 4 gives me what? Hopefully -7. And then -1 minus 7, -8. All right. So I get the square root of 49 plus 64. Square root of 113. These instructions said round to the nearest tenth. Round to the nearest tenth, okay? So that means I want you to plug that into your calculator and round to 1 decimal place. So when you do that, you should get 10.6, okay? 10.6. So the next one, this is midpoint. So for midpoint, it's actually really simple. You're just going to take the x's and add them and divide that whole thing by 2. Take the y's and add them and divide that by 2. So negative 10 plus 2 is negative 8 over 2. 3 plus negative 2 is 1 over 2. You do want to simplify these fractions if possible. Negative 8 simplifies to negative 4. 1/2 is as simple as it gets, so you would leave that one alone.